All right. Good afternoon again, and this is the last technical presentation before the very last keynote there. So we have Jake Petroules from the Qt company. He's going to talk to us about cubes and the newest and greatest build system for Qt.
All right. Thank you, Gabriel. Can everyone hear me all right? Excellent. So I'm going to be talking a little bit about cubes, which is our upcoming build system in the Qt project. So the reason cubes came about is because we've had a lot of difficulty extending QMake over the years. QMake has grown very large and very hard to maintain because of architectural decisions made early on and compatibility concerns that we have to keep up with over the years. So Cubes began as a research project at Nokia back in 2010 as a response to the need to replace QMake to have a better build system. There have been some attempts before. There was the QtWS build system back in the late 2000s, and that never really took off. And so far, Cubes has been doing well. It's been fairly well received by our customers, and we have quite a few commercial customers using it so far. So we're hoping this will finally be the build system that we can replace QMake with. The most interesting thing about Cubes is that it does not rely on make files. So unlike most of the build systems you're familiar with, like QMake and CMake, which are makefile generators and use a high-level project description in a tool-specific language, like the CMake language or the QMake language, and then generate makefiles, which actually perform the build commands to create your object files and executables, shared libraries, and so on. QMake does all the work itself. You write your projects in a high-level language, which is based on QML and JavaScript, and therefore very easy to understand and familiar for Qt developers. And then additionally, QMake itself undertakes the task of executing the compiler and the linker and all the other tools needed to build your applications. And of course, it's open source and cross-platform. So Cubes originally stood for the Qt Build Suite, but we just backronymed it to Cubes, which stands for nothing, kind of like DVD, in order to de-emphasize its relation to Qt. Because we want to convey that this is a very general build tool. It's not something that's meant to be only used for Qt or only used for C++. Now, why are we doing Cubes? As I said, we need a replacement for QMake because it's very old and it's very hard to maintain. And the existing build tools that are out there don't really meet our needs. Qt is not only in the business of providing a platform, an application development framework, but we also want to provide amazing developer experiences. And with existing tools, we can't offer that. We need something better than CMake. So Cubes should go beyond Cubes. Cubes should go beyond Qt. It should go beyond C++. It should be able to build projects that use any toolkit or any language. And a lot of QMake's maintainability issues are evidenced by the delay it caused for the 5.8 release because we had to do the Qt Lite project to make QMake more suitable for building such a large project as Qt and making it more configurable. And these are the kind of things that a build system like Cubes enables very easily. So as I mentioned, existing build tools rely on very obscure languages. I'm sure many of you have used CMake and QMake before. How many of you think the language is easy to understand and easy to write complex features in? I don't see any hands. So that's one of the things we want to solve with Cubes, because it has a very comprehensible and easy to understand language that's based on QML and JavaScript. Now, this talk is going to be mostly a high-level overview of what Cubes is about. It's not really going to go into many of the fine-grained technical details, but cover more just the general features that Cubes has and the problems it aims to solve. So I'll give you a little look at what the language looks like. So just looks like regular Qt quick code. You have top-level items, you have nested items, you have property bindings and JavaScript expressions. Oh, let me see if I can move this over. Yeah. So as you can see, it looks very similar to Qt Quick Code. You have a top-level item, which is a product or a module or a derived item of such. You can have nested items where you can configure dependencies, configure file groups, and so on. You have properties where you can specify properties of your build, such as compiler flags, linker flags, and other high-level properties, such as which version of an SDK you want to use or what suffix you want to use for shared libraries. And the great thing about this is that you can have very complex expressions on the right-hand side of property bindings, which allow you to do very complex things like providing a default info property list on Apple platforms with very complex logic about what default properties are in there. And this is something that's very difficult with QMake, having these very fine-grained, very specific defaults. So another thing that's very important for a build system is very fast incremental builds. And when your build system is a makefile generator, this is very difficult to do properly. I don't know if any of you have ever heard of the article called Recursive Make Considered Harmful, but it's a pretty famous article that talks about the problems with recursive make. And with recursive makefiles, you end up waiting a lot of time for the build system to do nothing. If you've ever tried to build Qt and maybe you're working on some examples, if you run make at the top level, you're going to be waiting for 10 seconds for the build to just compile one file and then go through the rest of the directories doing nothing. And because Qubes has a complete picture of your build graph, you don't run into this problem, because we can enable optimizations across your entire project rather than having this very incomplete view that Make has, where it just looks at an individual directory at a time and doesn't really have an idea what's going on in the rest of your project. So Qubes is built on top of a modular design. Unlike QMake, which is essentially part of Qt and very, very geared towards building Qt applications, Qubes doesn't have any Qt functionality in the core. It is just a generic build tool for any language, for any toolkit, for any OS. And all language and toolkit support is built from a limited set of primitives, like modules, rules, artifacts, properties, and file tags. I'll be taking questions after the talk. Another thing that is very important is building for multiple platforms. This is something that's kind of impossible right now with QMake, because you have to actually have different versions of QMake for each target you're building Qt for. So something we ran into recently with preparing demos for Qt World Summit is trying to build applications for iOS and watchOS. The way iOS and watchOS work is you have a watchOS application extension, which is bundled within an iOS application bundle. And there's no way to do this with QMake, because you have to have two separate versions of the build tool and two different installations of Qt. And there's no way within the build system to make these work together. Whereas in a build system like Qubes, this is very trivial, because the specification of something like a target platform is very specific. It's specific to a product. It's not this global property that applies to the overall build like it does with most other build systems. With most build systems, you're building for a particular platform, a particular architecture. That applies to the whole build, and it can be challenging to try and have multiple target architectures in the same project, or even multiple platforms within the same project at the same time. Another thing that's made very easy with Qubes is Canadian builds. A Canadian cross build is, this comes from GCC terminology, so there's a build, a host, and a target. The build machine is the machine you're building on. The host machine is the machine that you're building host tools for. And the target machine is the machine that you're building the target libraries for. So, for example, my build machine might be Mac OS, and I'm building an SDK that runs on x86 Linux and produces binaries for ARM Linux. And this can be tricky with a lot of build systems, because you usually just have one target, or maybe there is some separation between host and target that you have. But with Qubes, it's trivial, because we don't have this notion of an overall target platform. It's just whatever product happens to have whatever modules which pull in whatever rules can be built for any platform and any architecture. So with cubes, you define what platforms are available. You define whether there's a host or a target mechanism, or whether there's only one platform, or 3 or 5 or 7, it doesn't matter. In cubes, you can very easily just have a host platform and 1 or more targets. So there's really no support for Canadian cross builds as a concept, but it's just it's a subset of cubes having a host platform and 1 or more targets, host and targets both being a target in cubes. Oops. And also, we want to empower third parties to provide reusable build system components. And this is something that some of our users have done with QMake, but if any of you have ever looked at any of the PRF files within the Qt project, they're not very easy to understand, and the features you need to use are not very well documented or aren't documented at all. So writing new features and extending the build system with QMake is extremely difficult. And it can also be difficult with other existing build systems like CMake, because again, the language is hard to understand, it's very verbose, it's not very expressive. And this is something that's easy with cubes because it's based on QML, it has a modular design, and you can create your own modules and share them with the community, and actually build these on top of a stable API that we aim to keep compatibility with over the long term. Whereas with QMake, you're tied to the specific version of Qt that version of QMake came with. So it's very hard to maintain compatibility with QMake, whereas with cubes, this is something that we intend to make a lot easier. So as I said earlier, it's not just a build tool for Qt or just a build tool for C++. One of Qube's core goals is independence. We want to make sure that people don't look at this as a replacement for QMake that's just a Qt build tool. This is meant to be very generic. It's meant to be used for other languages. In fact, we currently have support for C, C++, Objective-C, some support for C++, Java, TypeScript, just as proof of concept to show that this is workable and possible. We even support building some packages for deployment, like Wix and NSIS. And we have some support for Node.js as well. And all of these languages are not built into Qt. They're entirely built in QML and JavaScript, and they can be hot plugged as you like. So you can write support for your own languages, and it's very easy to extend the build system. There's my mouse cursor here. So one very interesting way of describing cubes that one of our users came with is an artifact pipeline manager. And what this means is cubes is not even necessarily a build tool. Maybe you want to use it for other tasks. Maybe someone in content creation industry could use it to manage media files, Photoshop documents, and perform processing on them and be able to track the dependencies between those files in a very useful way. And also, one very good benefit of keeping cubes separated from Qt is that they have a separate release cycle. So you don't have that problem of being tied to a specific build tool version every time you upgrade your version of Qt. They're completely independent. And the support for Qt within cubes is just another module, no more special than Java or C#, which is, of course, not critical for the Qt project. So I'll talk a little bit about the unique features that cubes provides. Some of these, and at least in my opinion, are pretty interesting. So one thing that we aim to do very well in cubes is provide out-of-the-box support for popular platforms and SDKs. Now, a lot of people have complained that we should just use another existing build tool like CMake, which is much more full-featured and has already solved a lot of the problems we intend to solve with cubes. But where they do fall short is support for platform SDKs. If you want to build for iOS or Android with CMake, for example, you need to write your own toolchain file. And this is generally quite a long file with a long list of CMake commands specifying your NDK and SDK directories and your toolchain prefix and the architectures you want to build for. And we think this is something that should be built into the build tool. This is something that should be provided out of the box. And actually, for Android, we support most of the native build tools that the Android SDK and NDK provide. You can build multi-architecture APKs on Android with cubes right now. This is something you can't do with QMake. This is something you can't do with CMake. And actually, the only build tool I know of that can do this is the native build tool Gradle that Google provides with the new Android SDK. It supports the NDK, it supports DEX, AIDL, resources, manifests, all things that QMake and CMake do not support out of the box, you get with cubes for free. And on the Apple side, we also support a lot of the native functionality that you would find within Xcode, like bundles, asset catalogs, nibs and storyboards. And currently in development, I have code signing and provisioning working on iOS in a very automatic way. And I'm sure any of you who've developed for Apple platforms like macOS and iOS have run into issues with code signing. It can be very difficult to set up in your build process. And what I intend to do with cubes is provide an out-of-the-box experience where you can build an application for iOS and macOS, and provided you've set up Xcode with your developer account and downloaded all your certificates and private keys, other code signing things like entitlements, then you should be able to build an application with cubes, and it'll just work. It'll find all the correct information. It will sign with the correct identity based on whether you're building for the App Store or a debug build or macOS or iOS, all completely automatic, much like Xcode 8 now has automatic provisioning. Another interesting thing with platform support is device deployment. Currently, you can actually build an application for iOS with cubes and deploy it to an iOS device connected over USB. It just works out of the box. It currently requires a third-party tool to do so called iOS Tool, but you can simply install this with Homebrew, and then cubes will just pick it up automatically. And then another thing that we intend to handle with cubes is packaging and installation. This is something that most build tools don't handle. CMake does have some support for it with CPAC, where you can build NSIS or Wix installers, DMGs on Macs, and PKGs. But this is something we intend to provide very easily in cubes and make it part of your build process so that packaging is not something you have to relegate to a separate tool, but just be part of your overall build process and be an all-in-one tool that does everything from source code to executable that's delivered to your customers. And something that's a little minor, but I find particularly interesting, is that info.plist handling is extremely powerful in cubes. You have very fine-grained support. You can very easily add individual properties to your info plist files, which is kind of challenging with QMake, and I've actually heard a lot of people complain about the difficulty of doing so in QMake. Another one of my favorite features is generators. So cubes provides what we call the generators API, and what this gives you access to is essentially a tree of the resolved build graph after cubes has read your project and processed through it. And you can use this to implement quite a few different things. And a couple of the first things that we've done with this is provide generators for Visual Studio and Xcode. Xcode, you can see, has the little one there, which is not yet completed, but should be out with the 1.7 release. So we have very good IDE integration with Visual Studio and Xcode already using this generators API, which essentially transforms your cubes project into an Xcode PBX proj or a Visual Studio and Make-based project. And another interesting thing that we've used the generators API for is the Clang compilation database. If any of you are familiar with Clang, the compilation database is something that takes a series of your build commands within your build and then lets you replay individual compilation and linking commands. And you can use this for some extended integration with Clang Static Analyzer and whatnot. A minor thing, but just shows that this generators API is very generic, and what you can do with it is pretty unlimited, and we want to see what people come up with over time. And yeah, you can perform arbitrary processing on the build graph, so this is not really tied to providing IDE project files, but can be used for really anything. Dependency management is also another one of my favorite features in cubes, and this is something that is still changing quite a bit because in a lot of build systems you have link dependencies, and that's mostly all you have. And there's a lot more types of dependencies than just linking. For example, on Apple platforms, an application bundle might have a dependency on a plugin. You don't want to link to that plugin, but you want to embed that plugin within your application bundle. There's another type of dependency with Java files. You might want to embed a jar file within another jar file without necessarily linking to it. You might want to have a dependency on a plugin, but not embed it either, or link it. So we want to enable this very intelligent, abstract dependency management, which is very fine-grained and does more than just saying, this thing should be built before that thing, or this thing should be linked to that thing. You should be able to specify what a dependency means to the build system and what it means for your project. So this is meant to be mostly automatic, but also very configurable. So one of the things that Qubes handles very well is dependencies between libraries and applications. So for a shared library, you need to export linker flags and include paths generally to link an application to it. Qubes allows you to specify the include paths that you want to propagate to an application that's linking to your library using an export item. And it will also take care of adding the correct linker flags as well. But you can configure it as much as you need. You can even set individual properties that might add specialized linker flags for applications that are linking to that particular library, and so on and so forth. And also, we aim to make dependency tracking very accurate. I'm sure many of you have run into problems where you're doing a build, you change some file, but the build system doesn't pick up that change. It doesn't rebuild anything because it doesn't think anything changed. Or maybe you'll change some file in a plugin. Your plugin gets relinked, and then your application relinks to all of the other plugins. And you get this kind of chain effect, where if you change something, your build system rebuilds too much. And on the opposite side, if you change something, your build system doesn't build enough. And we aim to make it as fine-grained as possible so that you always get perfect incremental builds. The minimum amount necessary to build a project, never too much and never too little. And accuracy and dependency tracking is especially apparent in certain cases like with Java and with asset catalogs. Because with Java, you can have these anonymous inner classes. And it's not as simple as a.java produces a.class. You might have a.java produces a.class, a$1.class, and a$2.class. And the build system actually knows about this in Qubes and will properly track all that, properly clean out artifacts if you actually remove classes, unlike a lot of build systems which just try to delete everything and then rebuild everything because they can't track dependencies at that fine grain of a level. Running a little low on time. I'm almost at the end here. Qubes is very programmable. As I said, it has a modular library-based design, and we actually provide a native C++ API. That's what the generators are provided through. So if you want to provide support for additional IDEs or any other things, you can do that using the C++ API. We don't currently guarantee any long-term support for the Qubes API, so it'll probably break between releases, but we might try to stabilize that at some point. The APIs that we currently provide are fairly complete, but we're always open to suggestions if you need any additional functionality. And another thing that we aim to do well is provide very comprehensive and well-structured documentation. We've currently received some feedback that there are some areas lacking there, but this is something that we intend to do very well because we don't want to run into the QMake problem where there's no documentation for features, or the CMake problem where a lot of features are not very well documented and don't have a lot of good examples. We want to make this the most well-documented build tool on the planet. Because of its design, Qubes has very, very good performance enabled by its all-in-one design. No makefiles to contend with, no problems with recursive make. Building for multiple platforms is actually possible in parallel. If you want to build for macOS, iOS, and Android at the same time, you can do that very easily. It'll automatically use the number of threads on your machine. So for a quad core with hyper-threading, you'll automatically get the equivalent of make J8. You don't have to do that automatically. And we also have some ABI-based linking optimizations for C++, which I don't think I have time to cover right now. But pretty much, the more complete knowledge you have of the build craft, the more complex and interesting optimizations you can enable, and that's something we want to invest a lot of effort into. So in conclusion, we're currently porting Qt to use Qubes as the build system. We have this in a work-in-progress branch, which you can feel free to browse on code review and maybe even help out if you like. We do need a QMake replacement for the next generation of Qt. Whether this is going to be cubes or something else, we don't know for certain yet, but we are hoping that it will be cubes because it's been well received, it's gaining more and more adoption. We have people using it for third-party projects. There's a package manager now that's using cubes for its build dependencies. And even though CMake is established, we can do much better. And to create a new standard, it takes something that's not just a little bit different. It takes something that's really new and really captures people's imagination. And we hope Cubes meets that standard. Thank you very much, and we welcome your feedback. And we're at the end, so hopefully we have a few minutes for questions.
Yeah, we
got
have
one
time
up here.
for 3 questions. Yeah.
Yeah, thanks for the interesting talk. Sounds very interesting. But what I think is what stands and falls with a really good build system is system introspection, as AutoTools or CMake is doing. So the ability to find dependencies or to configure them. Is that possible already in Cubes, or do you plan that?
Yes, we do have support for finding dependencies on the system. We have support for package config. And we're going to be changing a lot around dependency handling because, as I said, we want to make them very fine-grained and generic and mean more than just linking. But yeah, finding system dependencies is going to be a big part of that.
Cool. Okay.
And we do have some support for it already with package config. Yeah.
Oh, wait, one. I saw you first.
Where does Qt stand on Python? Like, is there any Python support? And can I use it with Jenkins?
There's no specific Python support for cubes right now. I'm not really sure what that would entail because it's an interpreted languages. It's an interpreted language, so there's not really anything to compile there. So I'm not really sure what you're asking. Maybe you could, give me some more information later. As far as Jenkins goes, you should be able to use it in Jenkins like any other build tool, and I don't see any barrier to that.
Okay, one last question. Gentlemen. Yeah. Can you ask it?
Does Cubes have anything like when deployed Qt, but for Linux? Because the lack of Linux deployed Qt has been a very vexing issue to deal with.
Cubes actually intends to obsolete Android deploy Qt, Win deploy Qt, and Mac deploy Qt. We want to move all of that into the build system because the more complete knowledge you have of your build graph, the better it is. So we want to completely obsolete those tools. So in terms of Linux deploy Qt, we're not going to provide anything like that, but we intend to do something much better and much more powerful.
Okay, thank you very much. Please go to attend the closing keynote. It starts in a couple minutes, I think.
All right, thank you, everyone.
And if you have more questions for Jake, just come over. Yeah.
Yep.